So here, first we should immediately change these diameters into centimeters. So 2.5 inches for every 1 inch, it's 2.54 centimeters. So this is going to give us 0.984 centimeters. And here it's going to be 1 inch. And then for every 1 inch, there is again 2.54 centimeters. So this is going to give us 0.3937 centimeters. So now here, we're going to have to use the equation of continuity in order to solve for the velocity in the second section of that pipe. So here it's going to be the cross-sectional area of the first section times the velocity in that section equals the cross-sectional area of the second section times the velocity in that section. We know that the velocity in the first section is going to be 6.0 centimeters per second. So essentially we're trying to find the cross-sectional area. Here, the cross-sectional area of a pipe is simply going to be the area of a circle, pi r squared, and a sub 2 would be also pi r squared. So here we're going to use these values and we're going to divide it by 2 because this is of course the diameter. So we have pi d sub 1 over 2 squared, and then for the second cross-sectional area we have pi d sub 2 divided by 2 squared. And this right here is going to give us all of our constants needed in order to use this equation of continuity. So solving for this now, we're going to solve for the V2. Of course, we're trying to isolate that. So V sub 2 would equal the cross-sectional area of the first section times the velocity of the first section divided by the cross-sectional area of the second section. Plugging in for our constants from here and here, we have the cross-sectional area pi d sub 1 over 2 squared times v sub 1 divided by pi d sub 2 squared over 2. Pi's cancel out, and we can simply plug in for our constants. D sub 1 is of course that 0.984 divided by 2 squared times 6 centimeters per second. And then we're going to divide this by 0.3937 divided by 2 squared. And solving for this, we find that the velocity in the second section is going to be 37.5 centimeters per second. So again, as you can see, the cross-sectional area, if the cross-sectional area decreases, the velocity increases in that particular section. So one can say that the velocity is inversely proportional to the cross-sectional area in that specific section. And again, that final answer is going to be 37.5 centimeters per second in the second section of this pipe. And that's the final answer. Thank you for watching.